Okay, we had started section 9.3. We had taken a look at odds last time, and we had started expected value, and expected value is where we left off. So I'll remind you what the formula is for expected value. These are always problems that have numerical outcomes, and the likelihood or probability of those outcomes are also numerical, so we can actually calculate a quantity, and that quantity is the expected value of the situation. We had done an example with a roulette wheel, okay? And we're going to do another game. We're going to do a game show actually right now. So are you familiar with the game show Deal or No Deal? Yeah? I don't think my children have probably ever seen it, but they're in the Chuck E. Cheese's and the Dave & Buster's and all of those kinds of things now, so they're familiar with it from that perspective as well. And so the way that the television show works is that you choose a case, and then they narrow down all the cases, and eventually, if you go long enough, right, there's one case left, and there's your case, and you have to decide, which case to keep. That's the idea. So the contestant is down in this case to two cases with equal probabilities of being chosen. The cases have $250,000 and $10. If you're the banker and you want to give a reasonable offer to the contestant, but not too lucrative, okay, not too high, but reasonable, what deal would you offer and why? So we're going to take a look at what the expected value is of the situation. Now remember, expected value means if we played this game with these constraints multiple times, what would happen as a general, as an average. It's not what actually happens, right? What happens is you either win the $250,000 or you get 10. It's one of the two. It's not something in between unless you take the deal being offered by the banker. And we're going to try and figure out from the banker's perspective how that deal would be arrived at. So what we're doing is we're taking the expected value, and we have the value of winning one of the cases. Well, one of the cases is $250,000, right? And what is the likelihood or the probability that you have that case? Yeah, it's 50% or 0.5. You can do 1/2 if you want to do a fraction, okay? There's another case, and it's got $10 in it, and what's the likelihood that you have that case? Also 0.5. Okay, so grab your calculator, go ahead and multiply that out and add it together. And what would you get? Okay, did I write that right, Kiki? Okay, 125,005. Okay, so that's the mathematics here, right? And then we're going to answer the question being asked, which is what should you offer as the banker if you're trying to make it a good offer, but not too good of an offer, right? That's the question. So we'd offer around $125,000, right? We'll put the 5 in there, $125,005. Slightly more would be better for the contestant. Right, more enticing for the contestant. And slightly less would be better for the bank. So while from the perspective of the contestant, they're playing the game one time and there's one outcome, from the perspective of the banker, the game plays again and again and again and again and again, right? They keep having more and more contestants. So from the perspective of the banker, they don't really care if they win or they lose this particular one because on average, it all evens out, right? So their offer is going to be somewhere around $125,000, and then they can make a decision based on that number, whether to go up a little bit or down a little bit, but it's going to be close to that, or it's not going to be a reasonable offer. Make sense? Okay, we're going to take another type of quote-unquote game. Specifically, we're going to look at a lottery. All right, in this particular lottery, we know that the odds of winning the lottery are 55 million to 1. Those are some high odds, right? 55 million to 1. Okay, so the first thing I want you to think about is what is the probability of winning the lottery? Okay, so we talked before about how odds, because this says odds, and probability are related. The first thing I probably want to make mention and make for sure that you're careful of is that this is not 55 to 1. It's 55 million, right? So just writing that out in a numerical form is probably a good idea. I used to have a shirt that talked about orphans in the world, and it says, it was somebody's adoption, like a fundraiser shirt. And forgive me, I'm not going to remember the number, but it's something like this. We'll say it said 55 million. It didn't. It said something else. It said 55 million orphans, and it says 2 less because they were adopting 2 kids. Okay, 55 million, 2 less is not 53 million, right? Okay, so be careful. This says million. We want to make sure we're careful on that. All right, so these are odds, though. So what's the probability if the odds are 55 million to 1? Well, you're the 1. What's the denominator? Nope. Is it 55 million? It's close. You add the 1. Yeah, it's 55 million. 1. Okay, so remember, odds compares winning to losing or losing to winning in this case, right? There's 55 million people who lose, 1 who wins. So if there's 55 million lose, 1 person wins, how many people played? 55 million won. Are you with me? Okay. The difference in the value is very small in the calculation, but there is a difference that it will make in the value in the calculation, okay? So it's 55 million won. All right. If the grand prize is 14 million and a ticket costs $5, is the game fair? Now, do you remember how we decided if a game was fair last time?
They had an equal chance of winning and losing.
It has to do with equal chances of winning and losing, but there's a calculation that actually comes into play on that. Do you remember what it was? Let me see if I can find it. There we go. A fair game has an expected value of 0. So we can know if the game is fair if we calculate its expected value and it's equal to 0. And if it's not equal to 0, it's actually advantageous for somebody. Usually the person that's, running the game, not the person who's playing it. But that's what we're looking at, is whether or not the game is fair. So we talked about the fact that it doesn't always work as winning and losing, but in this scenario, once again, it does, right? I either win or I lose when I play the lottery. There's no in-between in this particular setup for this description. Now, there are some lotteries, right, where you might win $10 or you might win $30 or something like that, right? The scratch lottos, you've seen those probably before. Those are situations that are done a little bit differently. But the setup for this problem is not that. You either win, how much? 14 million, or you lose whatever the cost is for your ticket. Everybody good? Okay. So it says the ticket costs $5. All right, so 14 million, once again, please go ahead and think about what happens if you write out 14 million like this, right? That's 14 million. Okay, so we have our expected value that we're calculating. We have, and I'm going to write down to remind you how this was because we did it, but it's been 3 days now since we've done it. So we have the value of winning and the probability of winning. And then we have adding to that losing, right? The value of losing and the probability that we lose. And that's our calculations. Okay, so if we win 14 million. Yay, it's exciting. But we paid $5 to play, so we don't actually come out with 14 million more than we started with. How much did we gain? This is not a trick question. Please, somebody. Y'all got this. If I paid $5, somebody say it, 13 million what? $999,995. Very good. Yes. It's 14 million minus 5, right? Right? We earned, not earned, earned is a terrible word here. We were gifted 14 million and we had to pay the $5, handler fee or something like that kind of deal. Okay, so $5. What's the probability that we win? We already did it. 1 out of 55 million. 1. That was part A. That's probability we win. What happens if we lose? What do we lose? $5. And so this is a negative 5, right? Because it's a net change to our pocketbook of $5 less. And we haven't calculated this probability yet, but we certainly can. What is the probability that we lose? It's an almost guaranteed thing we're going to lose. What's the probability? 55 million over what? 55 million and 1. Okay? That takes care of every ticket, right? 55 million people lose. 1 person wins. That's the 55 million one that we're seeing across the tops of those numerators, and the 55 million one are the total number of people playing on bottom. All right, calculation. Be very careful. There's lots of numbers in this one. What we want to know is at the end what the expected value is for this scenario. What value do you get? It's negative. Yeah, and we'll go with 2 decimals since we're talking money, okay? Negative $4.75. Is the game fair? No. This does not equal 0. I know that's probably the shock of the day right there. Does not equal 0 on that one. So it's not fair. What it really means is that on average, when you play this game, you lose $4.75 every time. That's what it means. Okay? Here's the kicker, though. Lotteries are often said to benefit education. Nod your head if you've heard that before. Y'all are in education. You should have heard that before somewhere. When everybody tries to set up lotteries, they always talk about it benefiting somebody, and it's almost always education that they say benefits. Under these conditions, if all of the proceeds benefited education and 1 million tickets were sold, what is the expected value from the lottery sales? Okay, so this negative over here is negative 475 to whoever's buying. So let's say I'm the one buying, right? And Miranda is the one running, like the state lottery, okay? Miranda's running the state lottery. So I'm buying, that means I'm short 475, but it means you get to keep my 475, right? Okay, but she gets to keep my 475, and she gets to keep Taylor's 475, and she gets to keep Jordan's 475. And in fact, she gets to keep how many people's 475? 1 million people's 475. So how much money does Miranda, with the state lottery, get to keep? What would we have to do? Yeah, it'd be the 475 that the state keeps times the million people who played. So what would that be? Well, 4,750,000, right? That's what would benefit the state, or in this case, benefit education. But you see, that's not really the outcome, right? That's an on average if this is played over time enough times, right? Okay, but that's not really the outcome. There's one of 2 outcomes, okay? There are really only 2 outcomes. Actually, let me do it this way. 1 and 2. One outcome is that no one wins. So if no one wins, the state doesn't really keep $4.75 of every ticket. They keep all $5 of the ticket, right? Okay, this is not a raffle. Lotteries are not raffles. Nobody has to win in a lottery. Do you understand that? Sometimes people really get confused about that. Nobody has to win. Nobody has to win. You're not buying tickets for something. You're choosing random numbers, and the random numbers may not match anybody's. Okay? So if no one wins, then each ticket's $5. There's 1 million tickets sold. So the state keeps $5 million. Not 4,750,000, but 5 million. This is option number 1. So in this scenario, you're sort of making sure and rooting against everybody who bought a ticket. That seems sort of mean, doesn't it? I'm hoping that everybody loses their money at the lotto place in order to benefit education. Secondarily, one option is that someone wins. Now, also, if somebody wins, it can be more than one person that wins, but they don't each win 14 million. They split the pot when that happens, by the way. But if someone wins, they still took in $5 million, right? There were 1 million tickets sold, $5 a piece, 5 million is what they took in. But what does the state pay out if somebody wins? 14 million. So what happens if you take 5 million that you brought in and you spend 14 million? You would be negative. Yes, you would. Do you know how much negative, anybody? Yep, negative 9 million. Where is it coming from? Education? The bottom line? I don't know. It has to come from somewhere, right? The state is not the federal government. They don't just get to print it. It's not what our federal government should be doing either, but it has to come from somewhere. These are the two outcomes, and these are not the outcomes people talk about in that way, right? Yeah, it's interesting.